This is a replica of the Apollo 11 lander, the craft that touched down on the moon's surface on the 20th of July, 1969. But it's now nearly 50 years since Neil Armstrong took his first step onto the moon's surface, and 46 years since the last astronaut left the moon. For a long time, it seemed that lunar exploration had fallen out of fashion.
But now, for the first time in decades, it feels like we're on the verge of a lunar revolution. There are a host of new missions to the moon, either in progress or on the drawing board. And just last month, many of the world's leading lunar scientists gathered in Manchester to discuss this surge of interest in the moon. This month on The Sky at Night, in the first of two programs dedicated to the 50th anniversary of the moon landings, we'll be looking into this new era of lunar exploration and asking when it will be that humans return to the moon.
Here at the Science Museum in London, they're launching their Summer of Space by installing a new exhibit. The Soyuz capsule that brought Tim Peake back to Earth from the International Space Station in 2016. It's part of plans to commemorate the 50th anniversary of the first Apollo landings. But as well as looking back, there's now a real sense that we will soon be returning to the moon.
I was born in '72, so the year that Gene Cernan, the last man on the moon, left the surface. So it left a sort of legacy for me, and I'm really looking forward to getting back to the surface of the moon. And I think that's going to be hugely inspiring to a brand new generation of scientists and engineers.
This new race to the moon has already started. The Orion spacecraft is a collaboration between NASA and ESA that's been designed to carry the next generation of astronauts towards the moon, where the plan is to dock with the Lunar Gateway, a mini version of the International Space Station that will be in permanent orbit around the moon. From there, the crew will board a lander and descend to the lunar surface. Although the Orion capsule is already undergoing flight tests, the Gateway and the lunar lander are still very much on the drawing board. So most people thought that this was going to be a long-term project, taking 20 or even 30 years. But earlier this year, the Trump administration made a surprise announcement.
It is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years.
5 years seems like an impossibly tight schedule. So while I was in Manchester, I cornered NASA's chief scientist, Jim Green.
What's new at NASA and the moon? There's exciting plans ahead.
Oh, absolutely. I mean, our plans now are really exciting because we've moved our timescale up. We are planning to put the next man and the first woman on the surface of the moon by 2024.
Which is, in space terms, is incredibly fast.
It is very fast, but I mean, it's stuff we've done before.
So why does the moon matter as NASA's chief scientist? Why scientifically does the moon matter?
We're constantly making enormous progress understanding our planets with our robotic programs, not only at Mars, but even in the outer part of the solar system with Cassini, at Saturn, and then Juno at Jupiter, flyby of Pluto, so our initial survey of the entire solar system is now complete. Now we're moving into a more in-depth understanding. And that requires that we go back to the moon.
Why send people? We've talked in the past about the great success of robotic missions to Mars, to the outer planets you mentioned. Why people?
Well, for that, you have to think a little further ahead. And the little further ahead is Mars. Mars is a place, much like Earth, that has an atmosphere. It has carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur in its soils. It has nitrates. It has moisture in the soils. We can grow food at Mars. We actually can terraform Mars, live and work at Mars, okay? With that, the ultimate goal, and the fact that it is far away, what better place to practice than the moon? And so a lot of things that we're going to be doing at the moon is literally the same kind of things that we're going to be doing at Mars.
Well, look, it's really exciting. I want to ask you one last question, which is this. Lots of us are big fans of the space program and NASA, and we follow these missions and we look forward to them. I can't think of a mission that was developed in 5 years from scratch to launch.
Sure.
You know, Mars 2020 has taken a decade, and because these things are complicated.
Sure.
Are we really going to get there?
Well, it's not from scratch. We've been working on it for years, okay? We're nearly done with the development of the rocket called the Space Launch System, SLS, that will take us there. Our first test flights are going to be in 2020, next year. And then we will do several before we then land humans on the surface. You know, we're really almost probably 85% there. And so the schedule is such that we have a lot to do. There's a number of important things that we need to complete, but we have the ability to do it.
What's the most difficult thing that's remaining? What's the biggest jump?
Okay, to me, it's really all about the landing system with humans. It's all about that end phase, right, where we actually get down to the surface. We have a whole series of missions that are robotic that will look, test out, get us ground truth, and then figure out where we'll go. The astronauts are being trained on how the lunar surface looks and where they will go and the science that we want them to do. So we're making good progress there.
Yeah. So
that's what we got to
crack that, and then you can go in.
But we got good time to do it.
All right. Well, good luck.
Thank you.
Come back and tell us how you get on.
That would be great.
All right. You're on 5 years' time. Take care.
5 years back.
All right. Thanks, Jim. Nice
My
to
pleasure.
see you.
Thank you.
Cheers.
I have to say, I'm still very skeptical about that 5-year target. It's not clear where NASA might get the necessary funds. And so we'll probably be waiting a while before we see astronauts standing on the surface of the moon again. But there is a growing feeling that we will be returning.
There you go.
And as Maggie discovered when she visited the offices of pioneering architects Foster and Partners, plans are already underway for a permanent base on the moon.
I'm really excited about this. It looks fantastic. So, yeah, what was your brief for this project?
So what you're seeing here is a project where we were asked by the European Space Agency to design a habitat on the moon for about 4 astronauts who would stay there for a few months. And the idea was also very much in the brief to use novel and modern technologies to build this base.
So when you say novel and modern, what sort of thing are you talking about?
So here is the sequence of how the building sequence works. We bring from Earth a cylinder, and out of the cylinder we have this big inflatable that comes and provides us with a much bigger space. And so that's what you can kind of see here. The inflatable is there, yet it's very vulnerable, and that's where you see the little robots come in. And these robots actually scan the terrain. They pick up the dust of the moon, which is called regolith, and they use that to gradually 3D print a protective shell around this very fragile inflatable. But the idea is that the robots work a bit as a colony of ants, and they drive around and they kind of work together to start covering this structure until it's completely protected.
Why do you need so much protection? There's virtually no atmosphere on the moon. So what are you protecting against?
Yeah, so the moon has no atmosphere. So that means that you're very exposed from all the harshness of space. So there are very extreme temperature fluctuations. It can get very, very warm during the day, very cold during the night. There's also radiation coming from the sun that we are protected from here on Earth. And there is also micrometeorites. So they're very small, but very dangerous and very powerful. And that's why you need this massive shell to basically protect the balloon.
So what would it be like within the structure?
So these cylinders are very similar to the ones on the International Space Station, and that's kind of the core of our building. So that is where all the life support systems are, that's where all the scientific instruments are, and so on.
What are these structures here? Are they windows?
Yeah, what we've learned from the International Space Station is that this ability to look out and this connection with Earth is actually very important for the psychological health of the astronauts. And I think that's something that we explored a lot in this design, is also understanding that when you send people there to live for a while, it's very important that they are actually enjoying their work, but also enjoying their lives.
Yes. But when do you think this will come to fruition? Because the idea of lunar bases has been around for a while. Do you think something like this can come into fruition in the near future?
Again, it really depends on who has the commitment and the money to do it.
Yes.
If a company would say, we want to spend all the money in the world to do this, it could happen almost tomorrow.
So, the million-dollar question, would you go?
I would definitely go. I would like to come back, but I would definitely love to go and have a look.
Well, I guess we'll watch this space and see if it all comes to fruition in the future. Thank you.
You're very welcome.
Building permanent bases like this on the surface of another world will be the next giant leap forward in our exploration of the solar system. It may be many years away, but in the meantime, we're still learning more about the moon from the experiments left behind by the Apollo astronauts, as Pete has been investigating.
When we look up at the moon and see the same face always looking back at us, it is easy to think that it is a static, dead world. It can be hard to believe that this rock was once alive with volcanic and geologic activity. Even more surprisingly, a paper published by Nature in May revealed that seismometers left behind on the moon by the Apollo missions had picked up tremors. Moonquakes which show that the moon is still geologically active even today. So tonight, we're going to go looking for the evidence of that geological activity. Now, the moon is a big, bright object in the sky, but to get close in and see some surface detail, you need a telescope. Now tonight I want to look for some features which are pretty small, about a mile or so across. So I'm employing my 14-inch telescope, and I'm going to use a special camera on the back of it, which is called a planetary camera. It's a bit like a super version of a webcam. That's going to take lots and lots of individual images which I can process together, hopefully to give me a nice sharp image of the lunar surface. Right, so what I'm trying to do is locate a feature on the moon's surface called Roop's Rector, or the Straight Wall. I think some British astronomers actually refer to it as the railway because it looks like a straight line. Now, it's actually quite difficult to see at the moment because the phase of the moon is quite full, but I did manage to get a photograph of it the other day when the terminator, that's the line which divides lunar day and lunar night, was nearby. When that happens, the angle of the sun in the lunar sky is quite low, so it casts very dramatic shadows. And as you can see, the straight wall stands out very clearly. In fact, you can see that it looks exactly like astronomer Christian Huygens described, like a sword, where you've got the blade, which is the fault line of the straight wall itself, and then the Staghorn Mountains at the bottom. So it's a rather attractive feature on the moon's surface. But in reality, this is a fault line. It's believed to be 300 to 400 metres high, and it's actually quite a gentle slope, even though it looks like a sheer cliff edge when you see photographs of it. The moonquakes detected by the Apollo seismographs have recently been discovered to emanate from similar smaller faults on the moon's surface. These so-called thrust faults are too small to be seen from the Earth, but can be seen in this video built from data from NASA's Lunar Reconnaissance Orbiter. It's thought that the quakes from these faults would register between 2 and 5 on the Richter scale, strong enough to dislodge boulders that leave tracks as they roll across the moon's surface. Geologists believe that the quakes are happening because the moon is still cooling inside, and this causes the surface crust to shrink slightly, giving us cracks in the surface. Fascinatingly, these quakes happen most frequently around apogee. That's when the moon is at the furthest point in its orbit from the Earth. That's when the tidal stresses due to the Earth's gravity are at their greatest. If you want to know more about what you can see on the moon from here on Earth, you will find my moon guides along with this month's star guide on the Sky at Night website. Happy moon gazing.
So far, we've looked at American and European projects. But they are by no means the only nations sending missions to the moon, as I discussed with Science Museum curator Doug Millard.
This is it. This is Apollo 10.
So the Apollo 10 command module.
That's right. This is the actual one. Charlie Brown, of course, that was its call sign. Went around the moon 50 years ago, and it was the dress rehearsal mission for the Apollo 11 landing, just 2 months later.
But that was 50 years ago.
Yes.
And now it seems there's a resurgence in a sort of interest in the moon. What do you think's driving that?
Well, I think Apollo, in a way, sort of blotted out interest for a long time. How do you follow Apollo?
Yes, it covered so much.
It does, but we have new generations now, coming to the subject with renewed interest. We have new technologies, a little bit cheaper than they used to be. Apollo showed the way. We now know how to get to the moon, how to land on the moon. Doesn't always work. So there's a greater availability for going to the moon.
During the sort of Cold War, during the space race, it was sort of the Russians and it was the Americans. Who are the major players now?
Oh, well, they continue to be significant players. European Space Agency, India, China. China are, in some ways, replicating what happened during the 60s. They have a very carefully planned strategic space plan.
In January, the Chang'e 4 mission gave us our best ever view of the far side of the moon, as the Chinese became the first nation to make a soft landing on the side of the moon that is permanently hidden from the Earth. The data the lander and its rover has collected is already transforming our understanding of the geology of the far side of the moon. The mission even managed to successfully germinate cotton seeds, the first indication that it may one day be possible to grow crops on the moon. These were major breakthroughs, and the signs are there is much more to come.
They are now, this year, looking at a sample return, which will be a lot harder to do. It's only been done a few times before.
Because that's going to the moon, landing
Yes.
on the surface, scooping up, and then coming back home.
And bringing it back here, yes.
And so what are China's plans for the future?
I'm sure within a couple of decades, maybe, we will see Chinese astronauts on the moon.
So as well as these countries pushing forward to the moon, we also have commercial companies looking at the moon as well.
Well, that's right. And just recently we had an Israeli company which didn't quite make it. The spacecraft crashed. But it does raise interesting questions about commercial activity on the moon.
When you say commercial activity, are there laws governing it at the moment?
Well, there's an outer space treaty which was first signed in 1967, and there's a moon treaty, but it needs revisiting. It's not quite clear what is possible, what is permissible. You might have space tourism at some point in the future, and there are ethical questions about whether we want to continue doing that, or whether we should treat it as a wilderness, much as we do the Antarctic.
Well, let's see how it all pans out in the future, but thank you, and it is lovely to see the module.
Real thing, thank you.
Thank you.
Back in Manchester, I found scientists who were also preparing to return to the moon, with missions that will help pave the way for the next human visitors. Simeon Barber's project is looking to find water on the lunar surface.
What's particularly exciting about getting to the moon?
The moon's an amazing place. And I think we forgot that for a while. And I think that there was almost a feeling that we'd been to the moon and done that. So one mission that I'm working on at the moment with the Open University is supporting the European Space Agency, who are collaborating with Roscosmos in Russia. And the spacecraft is called Luna 27, and it will land near to the South Pole, where we expect there to be elevated levels of water in the soil or just below the surface of the soil.
It's still odd to me that we talk about water on the moon. I think the moon was supposed to be this dry place, and yet there's all this focus on water.
That's right. Partly that's because the samples that were brought back by the Apollo missions and Soviet lunar missions were generally from equatorial regions. And
so it's like going to the Sahara Desert on Earth and concluding that it's dry.
Yeah, but the new missions that are being planned now are actually going to a completely different part of the moon anyway. They're going to near polar regions. So we know that these regions are amongst the coldest places in our solar system. They're minus 200 degrees C or colder. These craters that never see the sun and have not seen the sun for billions of years. So these temperatures are cold enough that molecules such as water, if they migrate around the surface of the moon, when they reach these cold traps, they never leave.
Data taken at the moon's poles has revealed huge deposits of water ice hidden in the deep shadows of the craters. But we now believe there's also water stored within the lunar rocks themselves. And Simeon's project is trying to find out how much of it there is.
So what's this in front of us?
So this is a spare copy of an instrument that we built to go and analyze samples on the surface of Mars. And the reason it's here today is that we're using parts of this instrument to inspire us in designing a new instrument to go and study the moon.
So what does it do?
This instrument's designed for analysing solid samples that are maybe drilled from the surface of the planet. The samples are popped inside this port here, close the lid, and then we heat those samples up, it releases gases, and we analyse those gases to work out what they are and in what quantities they're present in the sample.
Well, so on the moon, what would that help you do?
The moon is kind of a witness that has been a companion to Earth through time, and it stores information there. By going there and accessing and studying this water, we can kind of unravel the history of water near the Earth through time.
So you go to the moon to find out about the Earth, and could the water be useful?
Absolutely, yeah. So the idea is that if we can find resources on the surface of the moon, and water is a key resource, so it's great for servicing human bases.
Yes.
Drinking water, sanitation. But also, water is hydrogen and oxygen. So if you can separate the water into those constituents, maybe that can be used as a fuel.
It's nice because you do the same experiment, you get the science, but you're also planning for the sort of future of exploration as well.
That's right, yeah.
Well, I hope you get to the moon. We'll come talk to you when your instruments are on their way.
Please do, yeah.
Thanks a lot.
Thank you.
The idea of a lunar base like this is not a new one. Even at the time of the moon landings, people thought their development was inevitable. As Patrick Moore discovered when he met Neil Armstrong in 1970.
Do you think, from your knowledge of the moon, having been there, that it is going to be possible in the foreseeable future to set up scientific bases there on anything like a large scale?
Oh, I'm quite certain that we'll have such bases in our lifetime. Somewhat like the Antarctic stations and similar scientific outposts, continually manned. Although certainly there's the problem of the environment, the vacuum, and the high and low temperatures of day and night, still in all, in many ways, it's more hospitable than Antarctica might be. There are no storms, no snow, no high winds, no unpredictable weather phenomena that we're yet aware of, and the gravity is a very pleasant kind of place to work in, better than here on Earth, and I think it would be quite a pleasant place to do scientific work, and quite practical.
Today, the comparison with the Antarctic still holds true, as it's thought that any future moon bases will operate in a similar manner to Antarctic research stations. Antarctic bases provide facilities and living quarters for the hundreds of scientific missions that visit the continent. There are telescopes for studying the constant views of the polar skies. But these facilities also act as a base for geologists, climatologists, biologists, and other scientists. And it's thought that a lunar base would work in the same way. There is a huge amount of science that we would want to do on the moon. The far side of the moon is probably the best place in the solar system to do radio astronomy. Shielded from all the radio interference from the Earth, it should be possible to monitor the low-frequency radio waves that can't be detected from this planet. It's information that could tell us about the first moments after the Big Bang. There's also lots of life sciences work to be done. How can we keep astronauts alive and well on the moon's surface for long periods of time? But crucially, there's so much more to discover about the moon itself. Because, as Chris discovered when he met Katie Joy, we are only beginning to scratch the surface of our nearest neighbour.
This is a lunar meteorite rock, which we don't know exactly where on the moon it's been launched from. Chemically, it's similar to some places on the far side.
So this could be a bit of the lunar far side right here?
It could be. We are trying to investigate it and ask those sorts of questions. We're not quite sure exactly where it came from.
So we've spent the day talking to people excited about going back to the moon, but what as a scientist do we get if we get to go back? What's left to find out?
The moon's really unusual. It's incredibly large for a rocky body of its size compared to the planet it's orbiting around. So that tells us that it's unique in terms of its formation. It's geologically diverse, it's complex. There's different regions, white areas and dark areas that all formed in different ways.
The front and the back as well, the far side and the near side?
Yeah, there's asymmetry between the near side with lots of lava flows that have been erupted there compared with the far side, which is mostly white and probably formed early in the moon's history. We know that there are volcanic vent sites that tell us about volcanism. We know that the moon has been impacted with asteroids and comets through time. So it tells us about a lot of different scientific questions that we either can't access here on the Earth, or it tells us science questions that we can compare and contrast to other planetary bodies. The problem is a lot of this knowledge, these ideas, these models have come out of the data that we collected from the Apollo missions. We have this sample collection, but we only have been to 6 places, all within a relatively geographically limited area. And not only that, we know that the Apollo missions actually all visited quite a weird part of the moon. So, it's the equivalent of trying to understand the whole of the geology of Europe from just visiting, say, France or just one small country. It's that big picture perspective that we're sort of lacking.
So when can we expect some new lunar material?
So this year, it's really exciting. We have the next series of the Chinese missions going to the moon. There's going to be a lander visit the near side of the moon in a volcanic region in the northern part of the moon, and it's hopefully going to bring back a couple of kilograms of rock back to the Earth. And there are plans afoot through collaborations with several American mission proposals to go and collect samples robotically as well from different places. So the next 5 years, both robots and then hopefully human beings are bringing back samples of the moon to the Earth, and we can study them in our labs and do some really new, exciting research.
So what are the advantages of sending people on these missions? Why not just launch a robotic sample return mission?
So I think you can do both. Human beings have the capacity to do more complex science experiments and to also, inspire people. So it's not just about going there and doing science with crew. It's also about providing that human being contact to another world and acting as a focal point for how we go out there and how we explore. And to me, that's as important as the science that can be achieved.
Well, that I agree with, so I hope we get to see it.
So do I.
Thank you very much. Come back and tell us when you get some more samples.
That's all we've got time for this month, but join us in July for the second of our lunar specials.
Altitude 4200, here, go for landing, over.
We'll be joined by some old friends to look through the BBC archives to see how we covered the build-up to the moon landings 50 years ago.
We're dealing with the advanced technology of going to the moon with Stone Age graphics, like that.
It's fantastic! It's unbelievable!
Also, in the autumn, we'll be hosting a Sky at Night question time, where Chris, Pete and myself, as well as some special guests, will be answering your questions in front of a studio audience. If you'd like to submit a question, send it through to skyatnightqt@bbc.co.uk. Until then, good night.
The Sky at Night book is available now, and hear the incredible story of the people who made Apollo 11 happen, 13 minutes to the moon on BBC Sounds. Tuesday at 9, Jupiter and its moons, with images from NASA's Cassini, the planets on BBC Two.